Hey guys, welcome back. So today's video, what we're going to do is we're going to learn how to identify sine and cosine equations. So how to identify, find the sine equation or find the cosine equation if all I'm given is a graph, right? So the question is, hey, here's this graph, and your job is to now kind of identify from a picture, be like, okay, well, here's the equation form, and that's what we're going to be doing. The method that we're going to use throughout these, I think it's like 3 or 4 examples, we first need to figure out if we're dealing with a cosine graph or a sine graph. So that's step one. Identify, is this a sine curve or is this a cosine curve? And I'll give a couple of tips and tricks of how to figure out who we have. We're also going to see in this video that we may have some negative sine or negative cosine graphs as well, and kind of how to deal with those and how they look. So that's step one. Step two, we're going to look at our graph and we're going to identify the amplitude, and that'll be A, the period, and we'll set that equal to 2 pi over B, the phase shift, we'll set that equal to negative B over C, and vertical shift, and we'll set that equal to K. And then we'll plug all of our variables in to where they belong. And again, whether we're using a sine curve or a cosine curve, and then boom, equation. All right, here we go. Let's see our first example. So step one, so here's my picture. Step one is, okay, well, is this a cosine curve or is this a sine curve? And the main way to tell the difference, sine starts from the midline, right? This is the midline of the graph. Sine starts from some kind of midline, goes up, back to the midline, down, and back to the midline. So the base graph of sine starts, it goes 0, then it goes 1, then it goes down to 0, then it goes down to -1, then it goes back up to 0. These are the y values of the base sine graph. So basically, how to figure out, like, is this a sine curve? Does your graph go up, come back, go down, and then come back? Yes, it's a sine curve, all right? So this guy is a sine curve, mainly because this is very close to the base sine curve. We're starting at 0, and then we're going to 3, and then we're going to 0, and then we're going to -3, and then we're coming back up to 0. So 0, 3, 0, -3, 0 really closely follows this pattern. This has got to be a sine curve. So I know I'm dealing with sine, so I know I'm dealing with something that y equals k plus a sine of bx plus c. All right, so that's step one. I know I'm using the sine equation. Step two, let's identify the amplitude. So how do I identify amplitude? Well, it's 1/2 of big M minus little m, absolute value. In other words, I take the tallest point on the graph, which is 3, the lowest point on the graph, which in this case is -3, big M, little m, so this would be 1/2, big M is 3, little m is -3. 3 minus -3, that's going to end up being +6. Half of 6 is 3. So my A is 3. So I got that part. I know my amplitude. My amplitude is 3. Let's look at the period. The period goes from, now I'm looking at the x values, x value 0 to x value 2 pi. So the period here is 2 pi. So the period is 2 pi. The period of the base graph is also 2 pi. So we know that our b then is going to be 1, but let's set it equal to 2 pi over b. This is how we're going to figure out our b. Multiply both sides by b. We would get 2 pi times b equals 2 pi. Divide out both sides by 2 pi. And we would end up with b is equal to 1. Right, because the period is unchanged. The period of base sine is 2 pi, so this period is also 2 pi, which means b is equal to 1. B's default is 1. A's default is also 1, and C's default is 0, and K's default is 0 as well. So let's look at phase shift. Phase shift, well, where does our graph start off at? Well, it starts off at 0. So remember how we graph. Phase shift is start. Phase shift plus period is end. So our phase shift here is 0. We didn't move left, we didn't move right. Sine graph starts at 0, so we have no phase shift here. But phase shift is equal to negative c over b, and we know that b is 1. So 0 is equal to negative c. This implies that our c is 0. Okay, and what about our k? Well, sine originally starts at 0, and we also are starting at 0, which means there's no vertical shift here. Sine starts at 0, 0. This graph also starts at 0, 0, which means we didn't vertically shift anything, which means k is 0. Okay? So now I have all my pieces. I know that a is 3. Now let me plug them in. So y equals k is 0, so there's no k. A, I know is 3. Sine b is 1, so that's just going to be x. C is 0, so I don't add it in. So the equation of this graph is 3 sine x. In other words, this is basically just the sine graph. We just multiplied the thing by 3. We stretched it out a little bit. Okay? But we went through all the steps also. And this is the process we're going to use for every single example. All right, let's look at the next one. So let's look at this equation here in this graph. Let's see what we got. So first thing, is this a sine graph or is this a cosine graph? And remember, we are either going to check, do we first go up or do we first go down? Remember, sine looks like 0, 1, 0, negative 1, 0. So let's look. We got 2, and then we got 5, and then it looks like we go back down to 2, and then we have negative 1. So it looks like there's a vertical shift, right? And then we go back to 2 here. So we go 2, 5, 2, negative 1, 2. So basically, see how there's 3 2 values here? So because there's 3 2 values here, these correspond with the 3 0 values here. So this also looks like a sine graph. The sine, again, goes up, comes back, down, comes back, up, comes back, down, comes back. That's sine. That's positive sine. So this, again, takes the shape of a sine curve. So that's the first thing to figure out. So we know we're dealing with sine. K plus a sine Bx plus C. Now let's find all of our pieces. Let's figure out our A. Amplitude, 1/2 the tallest point, which is 5, minus the smallest point, which is negative 1. 5 minus negative 1 is positive 6. 1/2 of that is 3. Okay. Let's look at the period. The period here, how long does it take to repeat? We go up, we come back, we go down, we come back. Here it is, the stops the repeat. And it looks like we go from 0 to pi. So my period is pi. And now I'm going to reverse engineer to get b. So if I know my period is pi, period is equal to 2 pi over b. So I'm going to solve this equation. Let's use this as a colon instead. So I'm going to solve this equation. So I multiply both sides by b, which will give me pi times b equals 2 pi. Now I divide both sides by pi because I just want b. Divide by pi, poop. So we get that b is equal to 2. So that's what you're doing. You're eyeballing the period, and then you're using the equation, whatever you figured out how long your period is, that's equal to 2 pi over b, and you solve that, and that's what pops out your b. So now I figured out my a, I figured out my b. Let's figure out if I have a c. So in c is done by the phase shift. So phase shift, I don't have a phase shift because I'm starting at 0. Sine and cosine both start at 0 x value. So I'm starting at 0. I start where I'm supposed to start, so I don't have a phase shift. If my graph started over here, I'd have a negative phase shift. If my graph started over here, I'd have a positive phase shift. My graph starts right at x equals 0, so there is no phase shift. So 0 equals negative c over b. B is equal to 2. 2 times 0 is still 0. So c is equal to 0. In other words, there's no phase shift going on here. This graph isn't shift over to the left or isn't shift over to the right. It starts exactly where it's supposed to. So c is 0. Now let's look at k. So sine is supposed to start at y value 0. Sine is supposed to start at 0, 0. But this graph doesn't. This graph goes 2, then 5, then 2, then -1, then 2. Right? So how am I getting from here to here? Well, I'm adding 2. Right? This would have been my starting point. All my zeros have shifted up by 2. And that's the check. All my zeros have shifted up by 2, right? This is a sine graph. Sine is supposed to start at 0, 0, but it's not. It's now starting at 0, 2. Therefore, since the starting point got shifted up by 2, that means the whole graph got shifted up by 2. So, which means I can figure out that my vertical shift here is 2. If one of your points has been shifted up, then all of the points have been shifted up by that exact same value. And that's the way to figure out the vertical shift here. And here's my A. So let's plug in. Y equals k is 2 plus A, which is 3, sine B, which is 2, x plus C, but C is 0. So the equation of this graph is y equals 2 plus 3 sine of 2x. All right, let's look at this graph. Now, if you notice, the shape is a little bit different here. I'll give you a second to kind of look at it. Like, why? This is a little different, but why is it different? So I'm going to tell you why it's different. Because that's the point of the video, right? So this looks like a sine curve, but it looks funny, right? Because sine is supposed to go up. Sine is supposed to start, go up, come back, go down, come back. That's what a sine curve is supposed to look like. Well, notice the curve that I have does exactly the opposite, right? Where I would like the curve to go up, the curve goes down. But it follows the exact same pattern that a sine curve would follow, but it just does it in like basically the exact opposite way. That means I'm dealing with a negative sine function here, okay? If your function mirrors your base function, in other words, it's an exact reflection, it's just like an exact reflection across the x-axis, sine is supposed to go up first. If your graph goes down first, you're either a cosine graph or you're a negative sine graph. Cosine is supposed to go down first, okay? So if your graph goes up first, then you're either a sine graph or you're a negative cosine graph. And then you have to figure out, okay, whose pattern do I match? In this case, this matches the sine pattern and the sine shape. It's just a reflection, right? It's just the sine graph, but it's the opposite, which means we're going to be using negative sine. Boop. So we know we're ultimately going to end up with negative sine. So, but we're still going to look like y equals k and now minus a sine Bx+C. So we're going to have a minus here because our graph got flipped. Right? Think about parabolas. Parabolas that open upwards, positive. Parabolas that open downwards, negative. Right? That's all the negative does, is it flips it. If it was opening up, it's going to now open down. Okay, let's continue on. Let's find our amplitude. We're still going to look for highest and lowest points. -5 is my lowest point. +5 is my highest point. Okay, cool. So my A is 1/2 highest point minus lowest point. 5 minus -5, that's a 10. Half of that is going to give me 5. So I got my A. Let's look at my period. Period. Okay, we start here, we go down, we come back, we go up, we come back. So this is the length of the period here. My period goes from -0.5 to 1.5. What's the distance between these two? The distance here is going to be 2. All right, from -0.5 to +1.5, that distance is 2. So my period is 2. And 2 is equal to 2 pi over b. So now let's solve this for b. Multiply both sides by b. We get 2b equals 2 pi. divide both sides by 2, and we get b. 2's cancel here, 2's cancel here. We would get b is equal to pi. Okay, found my b. Let's look for my c. And we do have a c this time, right? Because sine is supposed to start at 0. But it doesn't. Sine is supposed to start at x value 0. But this graph doesn't. This graph starts at x value -1/2. So my phase shift is -1/2. Now -1/2 is equal to -c over b. But I know b is pi. Multiply both sides by pi. -0.5 pi is equal to -c. Negatives on both sides, so I'm going to cancel them out. 0.5 pi is pi times 1/2. Let's clean that up. Pi times 1/2 is pi over 2. Pi over 2 is going to equal c. Last thing, let's figure out our k. Do I have a vertical shift here? No, I don't, because the midline here is 0. If the midline of your graph here is 0, you're good. Remember, sine starts at y value 0, and this still starts at y value 0, so there is no vertical shift. We are vertically exactly where we're supposed to be. This graph wasn't moved up, and this graph wasn't moved down. 0 is our midline. That's your check. If 0 here, if the x-axis is your midline, there's no vertical shift in the sine graph. And the x-axis is indeed our midline here. No vertical shift going on, so our k is 0. So let's fill in everything we have, and we know we're dealing with, again, negative sign this time. So we have y equal to k, which is 0, -5 now, sine b, which is pi, x plus c, and c is pi over 2. There we go, and this is kind of our first glimpse at negative graphs. Negative graphs just open the opposite way, okay? Just think parabolas. Positive parabola opened up, negative parabola opened down. It's the same exact thing with the sine and cosine graphs. All right, this is going to be our last example and our first example of looking at cosine. So not only are we looking at cosine in this graph, but we're also looking at, there's a lot of things going on. So first off, a cosine graph, the base graph of cosine, just to kind of jog our memory, the base graph of cosine starts at 1, and then it dips down to 0, and then it dips down to -1, and it comes back to 0, and it ultimately finishes at 1. Getting a little better at these every time I draw them. There we go. So this is the shape of the base cosine graph. So let's look at what we have here, and let's look at what we have here. Well, this looks like this graph turned on its head, right? This looks like cosine, but flipped over. Where cosine is kind of like a cup, this is like a mountain, which means, hey, this is probably the negative cosine graph. And it is. Base cosine graph looks like this. This guy looks like the flipped over version, which means we're dealing with a negative cosine graph. So that was the first thing to figure out. This is a negative cosine graph. So our equation is going to look like y equals k minus a cosine bx plus c. Okay, but we're still going to do the exact same thing. So let's figure out our a. Highest point, 5. Lowest point is 1. 1/2. 5 minus 1. 5 minus is 4. Half of that is 2. So our a is equal to 2. Okay? Our period starts at 0 and ends at 2. So 0 to 2. So our period is 2. And so 2 then is equal to 2 pi over b. That's how you figure out your b. You find your period visually, and then you set it equal to 2 pi over b. Solve for b. Multiply b on both sides, so we get 2b equals 2 pi. Divide by 2, divide by 2. B is equal to pi. Okay, got our b. Next for phase shift, to find our c. Phase shift, no phase shift. Cosine also starts at x value 0. This graph starts at x value 0. The base cosine graph also starts at x value 0. It starts at 0, 1. This is also starting at 0, 1. So there has been no horizontal shift of this graph. It doesn't start over here and it doesn't start over here. It starts at x value 0. Phase shift is 0, which implies c equals 0. No phase shift here today. And then k, what is going on with the k? So where is the midline of this graph? The midline of this graph is here at 3. So in order to visualize this better, let's draw the positive cosine graph, and then we can look at, okay, was this thing shifted up, and if so, how much? Right, so this is the midline here, so I would be starting at 5. So this would be the positive cosine graph in green. Notice how it's literally just the opposite thing. All right, well, we're starting at 5. We're going down to 3, down to 1, back to 3, up to 5. Remember, original cosine graph goes from 1 down to 0. So it goes 1, 0, then it goes -1, then it hits 0 again. Green is probably not the best color. It goes 1, 0, -1, 0, then 1, okay? So where were the zeros on my graph shifted? Well, where's the midline of my graph? My midline of my graph is 3. The midline of my graph is supposed to be at 0. So it looks like the midline of my graph, which was 0, has now been shifted to 3, which means my k has gone up by 3. So I'll say that again. What I'm looking for is I'm looking at the midline of my graph. For the base cosine graph, the midline is supposed to be at 0. The same thing for sine. The midline of the sine graph is also 0. So if you look and be like, okay, well, where's my midline of this graph? If my midline of this graph is not at 0, that means my graph has been shifted either up or shifted down. The midline of this graph is 3, which means I have a vertical shift then of 3. So my k in this case is going to be 3. Again, vertical shift, check out your midlines. So let's fill in what we got. Y is equal to k, which is 3. Excuse me, I was going to write k. Y is equal to 3 minus a is 2. Cosine b is equal to pi x plus c, but we have no c. So y is equal to 3 minus 2 cosine pi x. So again, to review what we've done in every single example, we first identified, is this a cosine graph or is this a sine graph? And then we've also figured out, okay, well, is this a negative graph or is this a positive graph, right? Is this the version of the graph I'm used to seeing, or has this graph been flipped over? And then we find the amplitude using our 1/2 m minus m formula. And then we get our A, and then we find our period by visually inspecting, okay, how long did it take for this graph to repeat or start over, or how long is this cycle? And then we set that number equal to 2 pi over b. We solve for b to get our b piece. We figure out our phase shift. Where did this graph start? If it didn't start at 0, if it started to the left or it started to the right, wherever it started, that's our phase shift. And we set that equal to -c over b. And that'll solve for c, and then we'll have our c piece. And then we inspect the midline of our graph, and we see, hey, has our midline of our graph been moved from 0? Because both cosine and sine have a midline of 0. And if that midline has been shifted up or shifted down, then we have a vertical shift, whether it's a negative graph or a positive graph. Check out the midline, because the midline is always going to be the same. Basically, it's like your belly button. Your belly button's not going to move whether you're standing upright or you get flipped upside down, right? Your belly button's still going to be in the same place. And I guess it depends on your body, but in general, right, that's kind of idea. So check out the midline. The midline doesn't lie. So I hope that video was helpful. My suggestion now is to go and practice the more graphs you look at, the more that you can find their equation, the more that you practice, the easier this becomes, the faster it becomes, and then ultimately the better you get at it. All right, I'll see you guys next time. I hope you guys enjoyed this video, and as always, if you have any questions, please don't hesitate to ask.